home, then they'll be able to get it. So that's why I like to bring the parents in so they can see how I do it. Now, the basic of volume is really easy, okay? Because we start out using the cubes that you have in the Ziploc bag. So I often ask, well, what is volume? Because when we think about volume, we think about liquid, right? We want to think about liquid, but volume is not necessarily liquid. It can be any substance, a dry substance, liquids, or whatever. But it is the capacity that a container will hold. So that's what volume is. So we talk about that first so they understand what volume is. Once we talk about what volume is, then we go into cubic units. And these are the things that you have here. So we're going to measure volume in cubic units to begin with, but we're going to move on to some others eventually. But we start out with cubic units, okay? And then we use cubes to fill rectangular prisms such as boxes, and this is what I have here. So we're going to take these cubes and we're going to fill this box, and that will give us the volume for this particular box. But we're not going to fill it today because we don't have time to do that because it's going to take a couple. But in essence, that's what we do. We build these little blocks and then we place them inside of this box, and then we take them out and we can use these cubes to count to figure out what is the volume of this container based on cubic units. Not milliliters or anything like that, but cubic units. That's what we start working with initially. It's cubic units. All right, so we have a rectangular prism here, and then we're just going to use those small cubic units to fill the box to help us figure out what the volume is. So that's 1 cubic unit, and we have length times width times height, and that's going to be the formula for solving volume. Okay, so it might be measured in inches, feet, or centimeters, etc. All right, so I use this PowerPoint to begin with so the kids can understand how we count the cubes. This one is simple simply because we can see all of the cubes. None of them are out of plain sight. We can see them. And so basically what we'll do is we'll just count them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the volume of this is 8 cubic units, right? Yes, 8 cubic units. Now it gets more complex because sometimes there will be some shapes where you won't be able to see all of them. So then we have to use the formula, which is length times width times height. So looking here, this is what I was talking about. Here, we can't see all of them.
Kaylee Jones, 5th grade.
Some of them are not in plain sight, right? So this is when we use the formula. Length times width times height. And this is just the basic of volume. We're going to get into additive volume in a second. All right, so when we do length, depending on how you hold the shape, the length might change, the width might change. But here, how long is this shape in cubic units? How long is it?
3.
3, okay? So that's our length. All right, and then the width of an object is how wide it is or how thick it is. With regards to cubic unit, how wide is it?
2.
2. And then, how tall is it? That's the height. How tall is it?
2.
2, okay? So now we're going to multiply. 3 times 2 is 6, times 2 is 12. So, 12 cubic units. Now, if the kids try to count them, sometimes they get kind of thrown off because there are some that you can't see. So when you have cubes that you can't see them, you want to use the formula, which is length times width times height. Now, we went over this in class, so they should pretty much understand that because that's the basics of volume. Are there any questions so far? Yes.
Do they have to express their answer with CU behind it, or is 12 okay?
They have to tell me cubic units.
Okay.
Yeah, they have to give me the units. They lose a point if they don't.
Okay.
So the problem itself isn't wrong, but they do lose a point if they don't have their units found. So that was a good question. All right, so no questions about this so far. All right, so now we're going to talk about additive volume. And this is where this comes into play, additive volume. All right, so if you will, take out this little shape of your Ziploc bag. And pretty much everybody should have this shape right here. So I got the kids to build this before you guys came. Okay, so this is still cubic units right here. We're still working with cubes. But there is a big blank space, right? So we can't do length times width times height because there is something missing. Well, we can, but we'd have to go back and subtract the part that's missing. And I showed them how to do that, but that gets kind of tricky. And so I don't want them to do it that way. So that's why we start with additive volume. Okay, so with additive volume, what you want to do is you want to break the figure apart. You want to break it apart. So we're going to take the top part of it off. And we did 2 separate colors so that we can easily take it apart. Alright, so now we have 2 simple shapes that don't have any missing parts, right? So now we can easily do length times width times height. Okay, so let's take a look at the first one. We're going to hold it this way. This way. Alright, so what would be the length of this shape? Holding it this way. What would be the length? If I'm holding it this way, this is the length. What would be the length?
1.
Just 1, yes. Okay? So 1 times, now we're holding it this way. So this is the width. This is how thick it is or how wide it is. What would be my width?
3.
3. And then my height, how tall is it?
3.
3. Okay, so now we have 1 times 3, which is
3.
3. And 3 times 3, which is
9.
9. So this shape right here is 9 cubic units. And then you can count it if you want to. If you don't believe me, you can count it, and it's 9. And so you're going to have to do the same thing for the next shape. And ironically, this is the same shape. So we know that it's going to be 9 cubic units as well. So if we put them back together, excuse me, Miss Lofton. Miss Lofton. Okay. Which one is this? Is it the All right, my apologies. All right, so now that we've put them back together, we now have to add the 2 separate volumes. Does that make sense to everybody? We now have to add the 2 separate volumes because we put them back together. So 9 plus 9 is 18 cubic units. Now, this is the basis of additive volume. It's breaking those shapes apart so that we have 2 solid figures. However, it's easy when you're using these manipulatives because you can see it, you can manipulate it and figure it out what you have. On paper, it gets a little bit more difficult because we have to cut it with a pencil and we have to visualize it being separate, and that's where it gets tricky. Okay, so are there any questions about this? No questions about this? All right, so let's take a look at your sheet that looks like this. Let's take a look at your sheet that looks like this. Okay, so in class, basically what I do is I tell everybody we're going to cut our shapes in the same direction, okay? So today we're going to cut them horizontally. And everybody has to cut theirs horizontally even if they see it different because I want everybody to get the same numbers. So we're going to cut them horizontally.